Hi, I'm Peter Kerbal here from Datasciencing Consultants, making another video for Datasciencing.com. This is going to be a bit more of a technical video, since a lot of people have asked me for more technical videos. My last couple of videos, if you check out my YouTube channel, we're talking about type of clients I work with and some more non-technical data science work I can do, like data visualizations, dashboards, analysis, machine learning type work. If you're looking for other technical videos, those are from my earlier uploads on my YouTube channel, which again, there's also a link on datasciencing.com. In this video, I'll be doing an example of machine learning using the naive Bayes theorem, and it is working on a data set of customers at a car dealership, and going to use that data set to predict if customers in another data set will buy a certain vehicle. So here we'll check out the data set. So here we go. So we have user ID, there's like a customer ID, gender, age, estimated salary, and purchase. This is if they purchase the vehicle or not. So 0 is no, 1 is yes. So we are going to use their age and estimated salary to predict if a customer will purchase a vehicle, and that helps a dealership. For some examples, they need to know how many vehicles they need to ahead of time, so that they don't run out if they need 1,000 vehicles maybe, or 100, depending on what the prediction is, and see if it's even worth it to run the promotion, or the price point on the promotion. So here we'll bring in our, create these variables. So this is the Rx variable, the independent variable, and since we're going to use age and estimated salary, in Python it starts the rows and columns start with 0, so we want all the rows, there's no excluding there. So we're bringing in, and we're going to bring in columns 2 and 3. So with Python, so here's 0, 1, 2, 3. So these are columns 2 and 3. And for a y variable, we want, this is our dependent variable, and we're going to use our purchased as the only column in this data set that is dependent. So, and that's the 4th column, so it goes 0, 1, 2, 3, 4. So we're just bringing this column into our y variable. And next we will split our data set and then do some scaling just to make sure it's right formatted. So here in the splitting, we are taking 25% of the rows or the customers, setting them aside to compare later to our prediction, and the other 75% will be our training set here. So we'll see here, we have our data set is 400 rows, and we're training on 300, which is 75%. So that means it's going to use this data set to learn what the data will needed to predict if someone will buy a vehicle. So it learns from these 300, and then we compare it with these 100 after, just to see, and then so we can compare how well the modeling did, because we don't want it to be 100% accurate, because if it's 100% accurate, then it's called overfitting, and that means it's just the model is just useful. It's actually not useful at all, because all it does is predict what will happen with this data set, and we already know what happens because this is the actual values. We want it to be able to use the model for other data sets, like for other dealerships in the city or for other countries, because we don't want it to predict, let's say, like if the dealership we're using database from Winnipeg, and then it's only focused on that one dealership, you won't be able to use this model to predict what customers will do, like in Regina or Calgary. So we don't want it to be 100%. And here we will do the fitting to our training set. So we'll bring in naive base as a classifier and fit it to our X train and Y train. And now we will create the prediction. So it's going to use, again, from these 300 customers, is going to predict if they would buy the vehicle or not. And here is the test database. This is what they actually did. And we will compare it now with our predicted value. So this is what the model predicted someone purchasing or not. So here, for these 24, it predicted all of them correct, 23 out of 24. So one of them is wrong. So we'll use a confusion matrix to explore that better. But that's just an example showing how well it predicted. So it looks like it's really good. It's 100%, or at least from that example. And it's also not widely off. If there's like 10 or 20 wrong in there, that could be problematic. But we'll look at the full data set. So this is our confusion matrix. So this is our predicted value. So this is the model predicted that these 68 people wouldn't purchase, or these 68 customers, because 65 plus the 3. And it predicted that these 32 would buy the vehicle. And these are the actual values. So actually, these 72 customers didn't buy the vehicle, and these 28 did. So how this works is, so this is because we predicted these 65 wouldn't buy the vehicle, and they didn't. So this is a true negative. And here predicted these customers wouldn't buy the vehicle, but they actually did. So this is a false negative. And here's kind of the opposite, where here it predicted, model predicted these customers would buy the vehicle, and these 25 actually did. So this is the true positive. And here is our false positive. So predicted that 75 would, but they actually didn't. So if we add up the 3 and the 7, these are like the errors. That's 10 out of our 100, so it's 10%. So it's 90% accurate. So that's pretty good. It's not too high, so we don't have to worry about overfitting, and it's also not too low that the model is basically useless. And so it's a lot better than just a coin toss, because it's that'd be 50%. So 9% is really good. So we will now map this so we can kind of see, understand better what is going on with the classification, how it classifies all the customers. So that is a good model we can use for other dealerships across like your city or the province, country, whatever your need is. And that's just an example for a dealership. Let's say you had a international chain of whatever store company you have. So here we're going to visualize, this is the training set. Here's the, here we go. So this is all the customers, all these dots. The green ones here are the ones who bought the vehicle. These red ones are the ones who didn't. And this is where it classifies. This is kind of how it separates the group, how it learned. So these red dots are the ones who, so say, shouldn't or should have bought the vehicle, but they didn't. And these green ones in the red section here are the ones that sort of say shouldn't have bought the vehicle, but did, according to this data and how it trained it. So this is how it used the data set to classify or group customers along this line here. And this is these numbers aren't accurate. This is just kind of the age. This is obviously -2 years, and these aren't salaries, but this is generally like the higher. This is a higher salary, and this is higher. So this is higher age, and this is higher salary. So there's a group here that it predicts that have a low salary and middle age. this area here would predict, but it wasn't until actual a bit over the middle of the age of the data set, not so it's the middle age of the population of the whole like city, and this is kind of the middle line of for salaries. And so there is a group here that have high salary, like this section here that have high salary but lower age, that they don't expect to buy this vehicle. So and then again, this is the training set. Now we'll visualize what happened with our in our test set. Let's see what this is showing with our basically our confusion matrix. So this is what it predicts. So this is how it separates, and these are the 100 people that are left over in the training. We took out of the training set as our test set, and then this is what it predicted they would do. And see here, this is our confusion matrix. Okay, so we have 3 people that they predicted wouldn't buy the vehicle but did. And that's over these 3 here, basically. Because they oh, was I looking at this wrong? Let's see. So they actually did buy the vehicle. Oh, but it predicted they wouldn't. Yeah, so these are those 3 dots, and then here are the 4 dots, sorry, the 7 dots here. They actually bought the vehicle, but it so they shouldn't have, because this is the group of people who didn't buy the vehicle. So you can kind of see how it separated the groups again, and in the prediction of some of the errors, which are good because we didn't want, again, to be 100%, or else that would be overfitting, and then the model is useless. So it's 9% accurate, so this is a good model to use for the other dealerships, or if that same dealership then potentially gets another customer data set through some sort of promotion. People sign up for something, all of a sudden they have another 400 customers for added to their database from whatever method. They could use then this model to predict who would buy this vehicle.